Alright, let's move to the last part for this section on the ResNet. This ResNet allows us to build a very deep CEM with residual learning to help us. Before we mentioned that ResNet can achieve better performance with deep architecture, it can achieve the largest high accuracy score on the ImageNet dataset, and its depth will also be more than 150 layers. And you may wonder, is it true that the deeper model we have, the better performance we can achieve? So we can provide you with some learning curves first about the CEM model, right? So in this page, we show you the training errors as well as testing errors of the CEM model on one of the image dataset. It's called CFA10, right? I remember I also provide you with a dataset for the stage 3 as well, and you can play with it if you are interested in it. So we provide you the learning curve of the CEM model with 20 layers as well as 56 layers. So according to the training curves, we find that for the model with 20 layers, it can achieve better performance than the CEM model with 56 layers on both training and testing, right? So we find that actually a deeper CEM model, it will have a higher training error and a testing error as well. And similar phenomena has also been observed on other datasets as well for the CEM model. So from the plots, we find that we cannot say that the deeper the CEM is, the better performance it will achieve actually. Then you may wonder how this ResNet we showed in the previous page can achieve so better performance with a very deep architecture. And to answer this question, we have to introduce the architecture of the ResNet. This ResNet is actually composed by a very simple component or building component. It allows the model to do the residual learning, for different model architectures. What is the residual learning? So from a given input like x, we can represent its output by some layers, like convolution layers or some other layers as this fx, right? As this fx. So for the ResNet we mentioned before, and the way I show in the following, between the layers, it creates a highway to allow this input to be reproduced in the output. So it allows this x to be reproduced in the output again. This is called a highway. So with this highway, we allow this x to be reproduced in the output. In the other words, so the output by these layers will be what? So we can represent this raw output by these layers as fx, right? And combined with the reproduced of this input again by the highways, we can represent its output to be fx plus x. So the main reason why the ResNet will be successful is because of these highways. So this is a basic building block for the ResNet. Also the main reason why it will be very successful for very deep architectures. And in the bottom, we show you the comparison of this VGG19 with this CEM with multiple layers as well as the ResNet. So the plot is in the horizontal way, so we can view in this way, in this direction. So this is VGG19. Inside we have multiple layers for both convolution layers as well as pooling layers, right? We show here. It will have about 19 layers. And then we also show you CEM with 34 layers without any highway or connections. We just show you the architecture for the CEM model. And we can see that if we have a very deep CEM, actually it will not work very well. The main reason is the model is so deep, it's very hard to learn. We also show you the ResNet with 34 layers. And inside we create some highways among layers, right? We allow the inputs to be reproduced in the output again. In this way, this model can be built in a very deep architecture. Also, a deep architecture can lead to better performance as well. So you can see how this ResNet works. It allows this input to be to join into the output again. In this way, this input can be reproduced again and over again, right? Until reaching its output. So by adding these higher ways to reproduce this input in the output, it allows this model architecture to be built in very deep architectures. We show you the learning curve of the ResNet on the datasets. So we can see that, we compare the ResNet with 18 layers as well as 34 layers on the ImageNet dataset. So this is the ResNet. Then we can do a very quick summary for this section. In this section, we cover both the conventional image processing as well as the latest, as well as the convolutional neural net for you. We mentioned the working net for the MLP for image processing, and we also talk about the image processing operators with convolution operator definition, right? We talk about what is convolution and how to calculate convolution on images, as well as several key parameters to be set up for the convolution. And for the CEM model, we talk about what is CEM architecture, what is the pooling layer used for, and how to calculate it. and how the CN is a variance, and how to make the CN deeper, right? And we'll talk about the residual learning and what is ResNet. Okay, so for the after class tasks about this section, please read the corresponding chapters in the textbook. Also refer to the CN article as the extra reading materials. So for the project, a reminder, and it's all the time for you to start your stage 3 as well, which will be based on CN models. And we have a reminder for you for the homework 1 as well, which will be due by the February of the 4th up or the Friday midnight. And if you are interested in the CN, the source code in PyTorch, you can refer to this link. And if you would like to check the ResNet, this code in PyTorch, you can also check this link as well. Okay, so that's it for this section, and thank you enough for your attention.